Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let us show the proof for the derivative of tangent function. Previously, we have already identified and proven the rule for differentiating cosine and sine trigonometric functions. And the next four will focus on the remaining four trigonometric functions. We will start with the tangent. Now, we will not be using here the definition for a derivative, but we are going to look into the relationship of tangent using sine and cosine. Again, we will be showing that the derivative of tangent x as given here is the square of secant x. Take note, this is also equivalent to saying the square of secant x. Okay, so it's just like that. Again, we will not be using here a definition, but we are going to look into the relationship of tangent x being equal as the ratio of sine and cosine function on the same angle x. Hence, we will be using here the idea or the rule for differentiating a quotient. Okay, we will be using here the definition for the quotient. Hence, just like this one here, if f of x is tangent x, we need to show the f prime of x that will return to this value. Let's have a short review on the quotient rule. If we have a function f of x, which is a ratio of k and m, where m of x is not equal to 0, the first derivative of that is this. Copy the denominator, take the first derivative of the numerator, minus your numerator times the first derivative of your denominator, all over the square of your whatever is your denominator. Okay, so we are going to use this idea in showing that the derivative of tangent x is equal to the square of secant x with respect to tangent x being the the ratio of sine and cosine. So if tangent x is the ratio of sine x over cosine x, using this we can say, let me use this portion here, our k of x, the numerator is sine x, right? And our m of x, the denominator is cosine x. We need that here, but we also need their derivatives. Now, what is the derivative of sine x? We have proven this. The answer here is cosine x. How about cosine x? There's also a rule for that, stating that this should be negative sine x. By the way, make sure that you will not be interchanging a negative sign, and of course this cannot be interchanged because the operation is subtraction. So let us have it here, making this equivalent to tangent x using the quotient rule. The denominator m of x is cosine x times the derivative of your numerator, which is also cosine x, minus you will have the your numerator original. This is numerator original. You will have sine x times the derivative of your denominator, which is this negative sine x, all over the square of your m of x, which is cosine x. Okay, now look into what happens to our numerator. We have two sets of cosine multiplied by each other, so this is actually cosine squared of x, or again, looking into this, it's the square of cosine x. Negative times negative is plus sine squared x, all over cosine squared x. This is square, right? Okay, now what is the value equivalent to the sum of cosine squared x and sine squared x? As long as we have the same angle x and it's cosine squared and sine squared being added, automatically this is equal to 1. That's one of the trigonometric identities that we have learned, over cosine squared of x. This was our f prime of x. And what is actually this? 1 over cosine squared of x, or the reciprocal of cosine squared x, is actually secant squared x. With this, we have shown that if our f of x is tangent x, which can be interpreted as the ratio of sine cosine, its derivative is equal to secant squared x. So we have shown here, therefore, the derivative of tangent x is equal to the square of secant x. Thank you very much for watching. So what are you waiting for? Subscribe now.